This presents a bar graph comparing annual corporate expenditures. Now, what standard visual manipulation makes a bar graph misleading to viewers? To understand what makes a chart misleading, we first have to ground ourselves in what a bar graph is actually designed to do. Now, unlike a line graph that tracks continuous movement over time, a bar graph uses the physical height or length of a bar to represent a discrete quantity. Now, our brains are hardwired to compare the relative size of those bars. Now, if bar A is twice as tall as bar B, our immediate cognitive takeaway is that the value of bar A is twice as large. Now, the visual scale must accurately reflect the mathematical scale. This brings us to the core mechanism of visual distortion, truncating the vertical axis. Now, truncation means choosing a starting baseline for your y-axis that is completely different from 0. For example, starting a scale at 90 instead of 0 to show a trend between 91 and 95. Now, when you drop off the bottom of the bars, you amplify the differences between them. So a tiny 2% difference in corporate expenditure can suddenly look like an enormous 500% spike because the bars are starting near the top of their actual values. So this destroys the visual proportion and fundamentally misleads the viewer. Now let's look at our options to see why the other choices represent good, honest chart design rather than manipulation. Option A suggests using different colors for each bar item. Now, while too many colors can look messy, it does not distort the actual values or proportions of the data. Option C mentions arranging data chronologically along with the horizontal axis. Now, this is standard best practice for tracking time-based data clearly. Option D includes a clear legend explaining labels. This acts as a guide to increase transparency and not reduce it. Now that leaves us with option B, truncating the vertical axis, so it does not start at 0. This is one of the most common manipulations used in media reports and biased corporate presentations. By removing the 0 baseline, you twist objective data into a dramatic narrative that doesn't actually exist in the numbers. So for a bar graph to maintain total mathematical integrity, the y-axis must always start at 0. So in conclusion, data integrity requires an alignment between visual layout and numerical reality. So always look at the baseline first. If it does not start at 0, the visual differences are distorted.